I thought. All right. Most of it can be verbalized until you start getting the sinusoid functions, which is a lot of graphing, but.
Well, now we're doing like polar and rectangular coordinates.
Okay.
Okay, so find the two polar coordinates with 0 degrees. I guess that's
R.
Sorry, it's 0 degrees. It has to be between 0 and 2 pi.
Okay.
For each of the given rectangular coordinates.
Okay.
And it's 2, 5, negative 2, 5. Negative 1, negative 1.
Should we just do one at a time?
Yeah, okay, let's just do it one at a time.
Okay. All right. The equations you have to memorize to relate polar to rectangular are these. R equals, X equals R cosine theta, and Y equals R sine theta. And X squared plus Y squared equals
R squared, right?
Exactly. Those are the three primary ones. Now, you do end up in some situations where you have to use tangent, but these should cover most of these conversions.
Okay.
Okay, now let me just figure out if I can remember how to do it. So, let's see. You're my first student this year that's had these, so it's been a year since I've done these. Let me think about this a second. We're converting, so we want, let's just cross that off for a moment. What we want is R theta.
Yeah.
Okay, so here's the other thing you need to know. The tangent of theta equals y over x. But here's the tricky part. Theta is equal to the inverse tan of y over x if x is positive, and this is what's weird about it, but it's equal to the inverse tan of y over x plus pi if x is negative. And this is the first time in math you've ever really been concerned about the denominator only. In other words, usually these things have to do with the argument. Okay?
Yeah.
So this will allow me to solve for theta. Theta is going to be inverse tan of 5 over negative 2 plus pi.
Okay.
What is the inverse tan of negative 5 halves?
Let me type that into my calculator real fast. Hold on, sorry.
So when you're going from rectangular to polar, first thing you get is theta.
Yeah.
And then R will be a piece of cake, because R is just equal to the x-coordinate divided by the cosine of theta.
Yeah.
Same with Y.
Hold on, sorry, I can't find my calculator.
Okay, let me see if I've got mine. I do. So we
don't know where I put that thing.
What's that?
We don't know where I put that thing.
Yeah, let me do it on mine. Better if you do it on yours.
Yeah.
Much better, but if you don't have it, you don't have it. So I want to
Mm-hmm.
put in minus 5 divided by 2. So, oh man, let's see. So I get minus 68.19. That's a reasonable sounding answer for theta
Mm-hmm.
plus 180. So let's see if it checks out. In other words, theta is 111 degrees, 111.81.
Yeah.
Well, where would that graph? If I were to graph that point, I would go minus 2 up 5, so I'd be in the second quadrant.
Mm-hmm.
That certainly is 111 degrees. So it ballparks, correct?
Mm-hmm.
Okay. And now to figure out R, let's go over to these two equations. And R equals the x coordinate, which is minus 2, divided by the cosine of 111 degrees, 0.81.
Mm-hmm. Okay.
And that's all you need, because now you have theta and R. In other words, you don't need to use the second equation to calculate R again.
Okay.
Okay. Now, I don't know. Yeah, why don't you write these down, and then when you find your calculator, you can convert them to numbers. Because I kind of hate converting them because I don't know how many decimal points you're supposed to round off to.
Yeah, you're fine.
So
Okay.
we can just keep doing them. The tough part isn't the final number. The tough part is
Well,
setting it up. Yeah.
yeah, because I need to find two polar coordinates.
Okay. Oh, you want to define just two. Oh, and we only found one, right?
Yeah.
Okay. So let's look at that picture again. The rectangular coordinates were minus 2 comma 5.
Mm-hmm.
Polar coordinates were, well, we didn't figure it out, so we don't know, but we know it was 111 degrees.
Yeah.
And
Whatever -2 over cosine is.
no, let's just write it like that. Negative 2 over cosine of 111. That was
Mm-hmm.
it, right?
Yeah.
Okay. So if we want a different one, well, what if we go that angle with a negative r? Notice this r is a positive number because the cosine of 111 degrees is negative. It's in the
Yeah.
second quadrant. So you're going to have a
Yeah.
negative 2 divided by a negative. So that's a positive r that we came up with. Okay.
Okay.
We can also go in the opposite direction. So the opposite direction would be that minus 69 degrees.
Mm-hmm.
So there's theta.
Okay.
And r would be exactly the same amount, only it would be in the other direction, which would be a negative number.
Is this kind of what you did, but before you added the pi to the number before?
No, that's a special case. In other words, let me back up to that. Is all this does is get you in the right quadrant. And notice how
Oh,
it does it. In other words, if x is positive, then you're either in the first quadrant or the fourth quadrant, right?
yeah.
Well, if you're in the fourth quadrant, then the inverse tan is going to be a negative number. So it's going to leave you in the fourth quadrant. You're going to be exactly where you're supposed to be.
Mm-hmm.
But if x is negative, you're either in the second quadrant or the third quadrant. And your calculator never gives you the second or third quadrant answers. When it does inverse tan, it gives you the fourth quadrant.
Mm-hmm.
So in order to put it into the proper quadrant, which is the second or the third, you have to add pi to it.
Okay.
Notice that pi takes it from the fourth all the way to the second.
Yeah.
So one of the other answers is just to not add the pi and to reverse the direction of the r. I'm not sure you're clear about this. Let me just explain something, make sure you are clear about it. In the polar coordinate system,
Okay.
if that has a length of 1, then that is 145 degrees. Okay?
Oh, okay.
Well, what if I go this way and give it a length of -1?
And then it'd be like negative 45.
No, that's the same as that. And
Okay.
go the angle first, and in the second case scenario, I'm going to go 225 degrees.
Mm-hmm.
So I'm going to go all the way to there. But then instead of going from the origin out, because my r is negative, I'm going to go from the origin in the other direction.
Okay.
So I end up in the same point. So these two polar coordinates are the same. 145 degrees or -1, 220.
Oh, okay.
So it's important to realize that those two do the same thing. You do
Mm-hmm.
the angle first, then you do
Right.
the amount of r, but you go in the direction of the sign. If it's a positive sign, then you go in that direction. If it's a negative sign, you go the other direction.
Right. Okay.
And so when they say they want at least 2, well, once you come up with 1, you can get the other one really easily. Well, actually, there are only 2, I believe, in that domain they gave us. Remember, the domain they gave us was 0 to 2 pi.
Yeah.
Well, we came up with an 111 one.
Mm-hmm.
And,
it's negative
and -69, you could change that to, what, 291? In other words, you don't have to write it as -69. You could write it as 291, which actually you would need to do to be within 0 to 2 pi. -69 degrees was not in that domain.
Okay.
But 291 is.
Yeah.
So that answer is one polar coordinate, and that answer is another polar coordinate. As all I did was take 180 degrees difference,
Mm-hmm.
and use a negative r. Whatever r was in the first case, I'm using a negative r in the second case.
Okay. Well, okay, then let's do let's do another one then.
Yeah, these can be verbalized fairly easily.
Yeah.
And it doesn't matter which way you're going. We can go either way. Go from rectangular to polar or back.
Okay. This one is -1, -1.
So it's still going rectangular to polar.
Yeah. Yeah.
Okay. First thing to do is figure out what theta is.
Yeah.
So what's the general format for theta?
Theta equals inverse tangent. Yep. Inverse tangent plus.
Of what? That needs an argument, a ratio in there.
Yeah. Right. Hold on. Let me write this out.
Y over x.
Y over x, and then
Your book actually might teach this a different way. There are various ways to teach this formula. And in all honesty, this is my favorite, but all books don't teach it this way.
Yeah, okay.
Yeah, some books will actually give you all 4 scenarios, I happen to love this particular technique.
If
That's
x
what
is
theta is equal to if x is greater, if x is positive.
okay, and then tan inverse tan y over x plus pi if it's less than 0.
Yes, because that puts it in the correct quadrant.
Right.
X is greater than 0, it's in the correct quadrant already. But when x is not greater than 0, you get put in the wrong quadrant unless you add pi to it. Okay? So what's
Okay.
theta here?
Theta here is going to be, tangent is sine over cosine, right? So it's going to be inverse
Tangent is,
-1 over -1
yes. In other words, tangent
plus
is
pi.
opposite over adjacent. You don't really want to
Yeah.
work out tangent by sine over cosine. That's more math than you need.
Yeah.
Okay? But it's opposite over adjacent. And opposite is y, and adjacent is x.
Yeah.
I mean, if you draw a triangle.
I don't know. I had to think about that for a
Okay,
sec.
here's the angle. Here's our polar coordinate system. Okay, that's y.
Mm-hmm.
That's x.
Yeah.
Tangent of theta is y over x. The inverse tangent, that makes theta the inverse tangent of y over x.
Yeah.
So that's where we get this from.
And I really need to find my calculator. I'm gonna look again.
Well, we only got 9 minutes. You don't want to spend all night on searching for your calculator.
Yeah, okay.
I would say we go through this.
Okay.
Just make sure you can do this. In other words, do it exactly the way we did it. Okay, so what's y and what's x?
Y is sine, or is -1.
Here's our
And then,
rectangular coordinates. That's x and y.
okay, it's going to be -1 and 1. Or -1, -1.
So it's the inverse tangent of 1, correct?
Yeah, I guess, yeah.
-1 over -1 is positive 1,
Yeah.
plus pi, because x was negative.
Mm-hmm.
Okay, well, what's the inverse tangent of 1?
I don't know.
45 degrees. Some of these you really should memorize. Like sine of 30 is 1/2, and sine tangent of 45 is 1.
Okay.
So if that's 45 degrees plus 180, then it's 225.
Yep.
That's theta. And notice, by adding the pi, put us in the proper quadrant. We know we're in the third quadrant, right?
Mm-hmm. Yeah.
-1 is right there. Third quadrant. So theta better come up in the third quadrant. And it did.
Mm-hmm.
So now we need r. And we only
So it'd be,
need one of those equations. One of them is this one. And now we know what x is and we know what theta is. So r equals x divided by cosine of theta. Well, what is
mm-hmm.
that? That is -1 is x.
Yep. Divided by,
Cosine of 225 degrees is a negative square root of 2 over 2. Negative
okay.
square root of 2 over 2. And that whole thing becomes a positive 2 over root 2, which rationalizes to root 2. So the answer is root 2 is r, and
root 2, and then 225.
is theta. And now give me the second one.
And the second one would be, it would be negative root 2, right?
Correct?
Negative root 2. And then, so take away 120 from 225. And that's,
Yeah.
okay, hold on, let me just, it wasn't that what we got before, actually?
No, this is a different problem, but notice that both of my angles are in the unit circle.
Oh, hold on, 225 minus 180. So it's 45.
Right. Now let's graph it and see if that makes sense. Okay. So here's how I'm going to graph it. I'm going to start with the first one. That goes 225 to there. It's a positive r, so I'm going to go out root 2. There's my coordinates. Okay?
Okay.
Now let's do the second one. I wish I had a different, yeah, I do have a different color. We'll try this color here. This time I'm going to go up 45 degrees. So I would normally be going that way, only r is negative, so I go the other direction. I start from the origin and I go root 2 in the opposite direction of the way I would go if it was positive. So I end up right there also.
Okay.
Okay? And literally there are an infinite number of polar coordinates for this rectangular point. Because I could also go around twice.
Right.
There are only 2 in this problem because they limited your domain to 0 to 2 pi. So there's going to be exactly 2. I don't know if I could think of any others. I don't think I can think of any others because it kind of has to be on that straight line. And that's only 45 or 225.
Right.
And then I either have to go this way to get to that point, or I got to go in the opposite direction from the origin to get to that point. So, yeah, I believe there's only going to be 2 polar answers per 2 pi. If my domain was 0 to 4 pi, then I would have 2 more answers also.
Okay.
Before we go, let's at least do one where we go polar to rectangular. We haven't done one of those, have we?
I don't think we have.
Let's do it.
Okay.
We got 5 minutes. We can do one in 5 minutes. You got one?
Yeah, the last one is 0 and -3.
That's rectangular. Let's go the other way.
What is it? Let me try and find one. Okay, plot each -2 to -pi/3.
Okay. First of all, that's not 2. The way you read that is just like you read a set of xy coordinates. That is -2, comma, -pi/3.
Yeah, okay.
That's r, that's theta. Okay? And our job is to convert that to rectangular.
Okay.
Well, that's actually easier because now I can directly use these equations.
Yeah.
Because I have r and I have theta. So the x-coordinate is r minus 2 times the cosine of minus pi/3. Well, the cosine of minus pi/3 is plus 1/2. That's a 60-degree angle. It's in the 4th quadrant. So that's plus 1/2 times minus 2, x equals -1. Y, the only other thing we need, is minus 2 times the sine of minus pi/3. The sine of minus pi/3 is a negative in the 4th quadrant, and that is square root of 3/2. So the y-coordinate becomes minus 2 times negative square root of 3/2, which is a positive root 3. So my polar was minus 2 minus pi/3. My rectangular ended up being -1, comma, root 3. Now let's see if that works, because the one thing you can always do is lay them on the same grid. Okay? Well, let's do the polar first and see where we end up. First of all, I'm going to go minus 60 degrees. So there's that. But then I'm going to go in the opposite direction too. So that's the ray I end up with. And that is a length of 2. Okay?
Okay.
Now, my x-coordinate was -1. My y-coordinate was +3. Certainly puts it in the 2nd coordinate. Let's see if that's correct dimensions. If that's a 1, and that's a square root of 3, that hypotenuse would be exactly 2. So that is indeed the correct answer. In other
Okay.
words, once I come up with my XY coordinate, I want to check it graphically to make sure it gives you the same point. In other words, this is the point we were on. That point is -1 root 3, or the XY coordinates. Polar coordinates are -2, minus pi over 3.
Yeah.
And there's another set of polar coordinates that I could use. That, like I said, there's an infinite number of them.
Okay.
So when you're going from polar to rectangular, it's really easy. You just use those two equations, that equation and the sine. In other words, the y equals r sine of theta. Because
Yeah.
you have theta and you have r. It's going
Yeah.
from rectangular to polar that's a little more difficult. That's where you have to figure out theta first.
Okay.
Okay.
Well, thank you.
You're welcome. Simon, nice talking to you again. I'll talk to you later.
Talk to you later, man. See ya.
Bye-bye.